Okay, I'm going to talk about compound and simple interest. Okay, so Kevin has $3,500 to invest and wants it to go to 42 in 4 years. He can buy a moped. What's the simple interest rate? So I equals PRT is the simple interest formula. So in order to grow from that to that, the interest that you would make is $700. The principal was that I put in 35. The rate is what I don't know, and the 4 is the time. So in my calculator, I'm doing 700 divided by brackets 3,500 times 4. So my calculator gives me 0.05 or 5% interest rate. Wayne has 20 grand. He wants to end up with 15. He has opportunity to make 4.5% paid annually. So I see again simple interest, so PRT formula. How long will it take? So again, my interest is the difference between my final and my start. So 15 grand of interest. Oops, so P, I can put 20 grand to start. R is 0.045, and then the time is what I don't know. So in my calculator, I'm doing 15,000 divided by 20,000 times 0.045 in brackets. So I get 16.66, and since it's said to the nearest year, I can answer 17. Simple interest rate, I start reading that, so I'm going to start PRT. So here's a rate, 4-year. What principal would you invest if you want to have 1,500 at the end, 15,000 at the end? So I don't know my interest, and I don't know my principal either. So I have two unknowns. Do you understand that interest equals the final minus the start? So I do know that my final is 15,000 minus the start. So that would be the interest, principal, rate, time. Okay, so I'm going to put those two together. So that is 0.074 P. Now I'm algebraically going to solve this. So I'm going to add P, 1.074 P divided by, so that number works out to 1396.48 is the starting amount, the principal. Okay, another question that says simple interest, so I'm going to use that. The principal of 2,000, the interest rate as a decimal for 3 years. So how much interest am I going to earn? In my calculator, 354. Now, the rate of return. How much money did you make divided by the money you put in? So I made 354 and I put in 2,000. So if I divide that, I get 0.177, but I'm going to say it's a 17.7% return on my investment. So this is kind of the idea. There's a formula on your formula sheet. It's what you make divided by what you put in. Okay, we have two different investors. 6 grand, 6 years, 6% is the difference between this question. One is a simple interest and one is a compound interest. So Nura is simple. Midori is compound. So these are the differences in the formulas. Knowing all the numbers are the same, I should understand the compound interest will be higher. Okay, so interest, we start with 6 grand times 0.06 as a percent for 6 years. Okay, so the interest is $2,160. Midori, we start with our 6 grand. 1 plus the rate divided by the number of compounds. So this is annual compounds. And then once a year for 6 years. So really on this situation I don't need the 1 in there. So when I calculate that, I get an A of 851111. So we're trying to compare who is the more interest. So the interest on that is 2160. This number is not the interest. This formula represents the final. So the final minus the start 251111. So I was predicting right, the compound makes more interest. How many compounding periods? So you're investing 75 bucks, 10 years, the rate compounded semi-annually. So this is the only thing I care about if I'm going 10 years and compounding semi-annually. 10 years, every year you end up doing it twice, so you end up compounding it 20 times. Sean wants to buy a new sound system. He has 1,000, but he has half what he needs, so he needs 2,000. When can he buy the sound system? This compounded quarterly. Okay, so compounded. I heard the word compounded, so I'm going to this formula. So he wants to end up with 2,000. He has 1,000. The rate is 0.037. Compounded quarterly, so 4. And if we do this 4 times a year for however many years, we don't know. Okay, so to solve when your variable is in the exponent position, well, you could use logarithmics, but I don't recommend that. I'm going to go put this in my calculator as a y1 and a y2. So when I'm doing this, it's important that I put the exponent for x in brackets. Now looking at these numbers here, I probably want my y to go up to, I don't know, I'm going to go 2,500. So on my y scale, I'm going to go 2,500, or on my y max, I'm going to do a scale of 500. So there's that line, and I'm growing my money, and I want to see when my money is going to grow to that amount. So it looks like I'm going to need more x, so I'm going to go with, I'm just going to put in a 30 on the x. So when is that intersection happening? Enter, enter, enter. At 18.8 years. Which nearest year? We can answer 19 years. Estimate how long it's going to take 1,000 to turn to 2,000 using this interest rate, compounded monthly. So estimate, there's this little rule, the rule of 72. 72 divided by the interest as a number, not as a decimal, is going to approximate the double time. 24 years to double your money. That's what that formula does. Figure out the actual time. See how close we are. So same formula for compound interest here we just used. Kind of the same idea. We want to end up with 2 grand. We start with 1,000. 0.03 compounded monthly, so I'm going to have to change that to a 12 to the 12 times however many years. So I already had this in my calculator here, y1, y2, so I need to get rid of that 7 for percent and divide by 12, and then I need to change this to 12x. Okay, so that should help. Let's see for the same, oh, we already know 24-ish should be our x, so remember I set mine to 30, so I should be good. So when did my money reach there? Intersect 23.13 years. So that you can see how pretty close that approximation is.